Welcome back to Stephy's Academy, and we'll be solving this question under frustrums. And this is a cone, and this part is in a dotted. It's in dotted because it's cut off. So this is the full cone, and then this is the frustrum down here. So the formula that we're going to use, first of all, read the question, and the question says the frustrum of a cone has height 6 centimeters and the radius is 8 centimeters of 8 centimeters. Its ends are 4 centimeters and 8 centimeters. So the first formula we're going to use is V volume is equal to 1 over 3 pi h r squared big radius, which is 8, and r squared for the small radius, plus multiplying both radiuses. So first we're going to solve this part here. V is equal to 1 over 3 pi is 3.142 times the height is 6 for the frustum. So due to space I'll be solving here. So I'm going to put since here it didn't fit, we're going to move it down here. So 4 times 3.142 times 6, open bracket, big radius, which is 8, plus the small radius, which is 4, plus 8 times 4. So yes, so now we're going to punch this first half in on the calculator. So 1 over 3 times 3.142 times 6, and that's the value. Then the one in the brackets, 8 plus 4 squared. So here 8 squared plus 4 squared is equal to 80. So we'll write down the 80 plus, then 8 times 4 is 32. So 32 plus 80, we're going to solve what's in the bracket first, which is V is equal to 6.284 plus what's in the bracket is 112. And this multiplied by this outside is 6.284 is equal to, the volume is equal to 703.808 or 703 centimeter cube. 3 decimal. So as you can see, this 8 can be rounded off, so it can be 4 here. And that's the answer, the volume. So now we're going to use this other formula, which is the volume is equal to 1 over 3 pi big R squared times big H minus 1 over 3 pi small r squared times small h. So as you can see here, this was a full cone and this part was cut off, but in this formula this is for the whole cone and the part that was cut off. So now here this x, we don't know the height of the part that was cut off, so we need to find the height. So we're going to say small radius over big radius is equal to small height over big height. So the small radius is 4 for the smaller cone on top, and the whole thing, the whole, it's 8 is equal to, the small height here is x, we don't know. And the whole cone is 6 plus x. So 6 plus x. As you can see here, we can reduce this fraction. So it can be 1 over 2 is equal to x over 6 plus x. So we cross multiply. So 1 times 6 is 6 plus 1 times x is x is equal to, then 2 times x is 2x. And we put like terms together. So 6 is equal to, when this x goes this side to become negative, 2x minus x. So 6 is equal to x, 2 minus 1 is 1, and is equal to x. Yeah. So now this is the value of x here. And now we're going to solve the volume of the frustum. So V is equal to 1 over 3 times, radius is 3.142 times, the big radius here is 8. So 8 squared times the big height, we found the x is 6, and plus this smaller x, we found the x to be 6 here, and plus this 6, it's going to give us 12. So this will be 12 here, minus 1 over 3 pi 3.142 times small radius, 4. So it's 4 squared times small height, here this x is 6. So now we're going to solve. So now we can solve the equation. So if you put them in brackets, they can easily be solved on the calculator. So we punch now all the numbers here. So 1 over 3 times, so we put the brackets, 1 over 3 times 3.142 times 8 squared times 12 close bracket is equal to 804.352 minus 1 over 3 times pi 3.142 times 4 squared times 6 close bracket is equal to 100.544. So 804.352 minus 100.544 is equal to the same answer, 703.808. Then we're going to round it off to 3 significant figures, and this 8 we can carry the 1 to the next number, which is 3. So it will be 704 centimeters cube, and that's the volume for the frustum. So apart from doing it separate, you can also punch everything on the calculator so that it can be all done, not doing it in halves. So we say, open bracket, 1 over 3 times 3.142 times 8 squared times 12 close bracket minus open bracket 1 over 3 times 3.142 times 4 squared times 6 close bracket is equal to 703.808.